Good morning, my name is Ken Gracie. I'm here to share with you Parallax with our Peruvian and Ecuadorian friends, and especially to welcome the Corporación Tesla Tecnología Servicios in Ecuador. So this is very exciting for us to have a new customer there, and I would like to welcome you to Parallax and our distribution network, and especially thank Ana Cordero Clavillo from Instituto Tecnología in Sudamericano in Loja, and also Oscar Jimenez, and of course Leonardo Rulivo, if I pronounced that right, I'm sorry, and of course Joaquin, and the special Propeller developers on his staff, Jonas Carrillo and Sir Milton Leon and Byron Ganzahapa. So, today I'll show you at Parallax. First I will show you a few different propeller projects as we move around. This one is a heart rate monitor, and I am wearing a heart rate sensor on my chest right here. So if this goes fast, we're in trouble. And this is the DEFCON badge, which we just finished in August, also using the propeller. So why don't we start? We'll go outside and then do a tour through the entire building. Come on. So I'll give you a little history first on Parallax. Parallax was started 25 years ago, and our history is very strong in the Commodore and Apple II computers. Here is our propeller-driven VGA display, welcoming you today to our team, as well as the college students. This display is driven by a propeller on a Propeller Board of Education, and it's just simply connected to the VGA port, and we update this every day for guests that arrive. This is our main office area, which also includes a workshop area. Over here you'll see several microcontroller projects. So these are commercial products produced by our customers, and the first one is a 3D printer board. This is for radiant fabrication. And then the next one, this is a sound SD card sound playback system that's used in Disneyland and amusement parks in Southern California. Here's a flight controller for multi-rotors and quadcopters. This is a medical device which controls pumps and solenoids. And this is a DMX to RS-232 converter. And here is a solar panel controller in which analog A to D converters measure each cell. This is an altimeter, and it measures the distance and elevation from the time that we started up, and it's connected to a OLED display. And the next one is a 3-axis gyroscope. This is the Color PAL color sensor. So when I put it over a particular color, it will show you the color on the display. This one is an optical finger navigation sensor, like you used to have on the BlackBerry phones. This one is a compass, and for all of these you will find spin code in the object exchange and C code that's distributed with simple IDE. So you're looking at the Elevate V2, and I think we can actually take it outside and fly it for you, because Joaquin has told me that he would like to have some of these. So this particular one can carry about 4 kilos. Come along with me. Out here it's very loud because you'll hear the noise from our cyclone that removes the air from our manufacturing facility. So hopefully you can still hear me. So we will turn the radio on first, and then we will connect the quadcopter to its power. Separate power supply for logic, for the flight controller, and for the motors. It's 14.4 volts, and it pulls about 80 amps when it's flying. go, so let's go flying. We'll just fly right out here. We won't go very far because we need to continue our tour. This one can carry a big digital SLR camera, another quadcopter, 3 or 4 small robots, as high as you want to go. And this system has on it 2 propellers, and it's using the Hoverfly Pro. So it supports SD card, GPS, auto level, barometric pressure sensor, and accelerometer for full flight control system. This is the Arlo robot, and it's very similar to the Activity Bot, and it uses a Propeller activity board and 10 ultrasonic sensors. So very similar to the Activity Bot. And this particular robot is set up with an electronic dog collar. So at a trade show, it stays within the trade show perimeter, and it carries flags. These robots are the Arduino, Basic Stamp, and Propeller activity bots. So this is just a Propeller activity board, activity bot with 36 count encoders, lithium-ion power pack, and in this case the ultrasonic sensor detects distance, and an SD card stores the sound. This is the gripper. And this robot has on it this one has switches. These are mostly used in high school and university, but for middle school and for elementary we have the S2 robot, which is programmed all graphically, no code writing. Okay, let's go to the manufacturing. Come with me. This is our CNC router room, and this is where we build the very big robot parts, like on the Arlo robot. This machine has 10 tool changes, and it can build this entire piece in about 2 minutes. And coming this direction, laser cutters. Today we're cutting Elevate quadcopter top and bottom plates with a 125 watt Rabbit laser cutter. And this machine can produce about 20 or 30 parts per hour. This is our CNC machine shop, and this is where we cut metal, and today we're actually cutting robot wheels. How's it going, Chris? Good, good. These are the robot wheels. They start as a big piece of aluminum. We put it in here, in the vise, press the green button, and then we take out these parts. This is our electronic assembly area. This side is our surface mount, that side is our through hole and test area. I'll give you a quick tour. This is our solder stencil machine. So we put the printed circuit board underneath it, and then we press solder through the stencil. And then the board comes out, and it goes here for a quick inspection, and then directly into the pick and place. And the pick and place machine is loaded right now with about 25 different reels, and it will place, I don't know how many parts per minute, but it will build a whole panel of products in about 2 minutes. It's very fast. Here's an example of something that just came off the pick and place. These are the Spinneret web server. So there's surface mount and some through-hole parts. This is our reflow oven. And this side is our through-hole area and also our testing area and programming. This particular machine is called Selective Solder, and it allows us to do through-hole soldering. This is a Selective Solder nozzle. It's CNC controlled, and it heats up, and then solder comes out, and then it goes underneath the board and it attaches the parts. So let's go look in the shipping area, but on the way, we see here some Propeller dip chips, which we are testing here. This is our shipping and our warehouse. And the first part of it is where we keep our chips. These are the Propeller chips, and the QFPs, which you often use on your projects, come in big waffle packs like this. This is about 2,000 chips. They're actually fabricated in Austria, and then they go to Taiwan for packaging, and then they come to America where we test them and sell them to you. So today we have going to a customer 100 ultrasonic sensors, many XB-RF devices, relay boards like this one for driving high voltage, or perhaps a very small version of it, single relays, which are very useful all the time, passive infrared sensors, gyroscopes, compasses. In here you'll see a whole bunch of our robots. And Parallax, of course, we design and manufacture the propeller, but we also support a very popular product. This is the Basic Stamp Bobot, which has been available for many years. There is a version with Arduino called the Arduino Shield Bot.
Yeah, 200.
And there's also a version with the propeller, of course, called the Activity Bot. And all of the source code and documentation is free, all of the objects, everything. So if you don't want to buy a robot kit, you can build your own and use all of our code examples. You already know, all you need is a propeller, EEPROM, and a crystal. And then you have a complete propeller circuit. So we'll go into kitting now. This is where we put everything in the boxes. This is the kitting master. So he makes it happen. He does this every day for many years. We're in the second warehouse now, and this has all of our material for robots and for our boards that we build. This is one of our mechanical prototype areas. So in here we prototype and we build things like the Arlo robot, motor mount wheel kits, changes to our robot chassis. The idea is that anything we draw, that we can also manufacture it here in Rocklin. So our time to prototype to production is very, very fast. For example, this battery charger, this idea we created, and within 2 weeks we were manufacturing them. We can prototype and do manufacturing here. A very fast process. And this is our education area.
Oh, there must be a tour. Hello.
This is Andy Lindsay. Andy's books include these, and then also the C learning system on learn.parallax.com. And it would be good to get a look behind them at some of our prototype robots that we're working with.
Yeah, that's the prototype repair area.
The graveyard for...
Yeah.
Hi, Stephanie. Hello. Get a quick look in her cabinet of all these robots in various states. Now this room, this is our training room. So if you were here today with us, all of the students from your university could sit down here, and then we can do a propeller course right here. It's very, very useful. This is for our trade show displays, and it's an infrared decoder. So when you press a button on the remote, it will decode the signal and change the pattern. Each of those neon elements is on its own 120 volt relay. And the circuit consists of, if you can come get a close look, it's just a basic stamp connected to 8 relays. This robot is our quad rover. This is a gasoline-powered, hydraulically driven robot. It's a gas engine connected to a pump with a splitter that goes to 2 motors, and it's 4-wheel drive. The front and rear are coupled together. We made 50 of these, and the primary use is for universities who like to do outdoor type robotic research. This is the Parallax DEFCON 20 badge. So the badge I showed you today is the DEFCON 22 from last August. This one is from 2 years ago. And we made 20 different types of badges, 16,000 units. And they have infrared transmitters, receivers, so they all communicate with each other. Each badge was for a different type of conference attendee. For example, Goon is security. This is speaker. These are regular humans. This is the Uber badge for the very best hackers in the world. I want to thank you for coming on our tour today and also really welcome you to Parallax. I'm excited to have a new customer in Ecuador and the coordination you have with the local university and also Joaquin's support. We're very thankful for this. We look forward to working with you. This year we hope to finish the Propeller 2, which we've been working on for 9 years. The 2 pieces of it are coming together nicely. The first part is the manual layout, the schematic for the A to D converter, which we've now finished. So the A to D is done, and we're working on the Verilog now. And then we take these 2 pieces, the Verilog and the A to D converter, to a company who synthesizes them and puts them together. And from that we will make the Propeller 2 chip. And we are expecting to do this in 2015. So I hope to see you soon. Thanks again for the tour.